Hello and welcome to this tutorial on another one of Too Tall Toby's practice models. This one is going to be a bit of a challenge here in Alibre because this is a multi-body part, and Alibre does not support multi-body parts, but we do have capability to create this as an assembly. So we're going through this in two steps. We're going to create this plastic curved part that's out of ABS. And then we're going to create the second part out of steel and then bring them together into an assembly workspace and check our final mass to make sure that we hit our target here of 627.8 grams plus or minus 0.2 grams. So let's take a look at what we have to create here. We have an arc or curved part here that's going to be at a radius of 160 millimeters, a total arc of 84 degrees, and a height of 16 millimeters, or thickness rather. It's going to be a shelled part with a wall thickness of 8 millimeters. It also has a round sleeve part that's 40 millimeters high with a wall of 6 millimeters. So also there's a full round radius on each end of the curved base part. So let's go ahead and get started. We'll start off with a profile to do well, it can be done either a sweep by creating a guide curve in here and then sweeping it along the guide curve. Ideally, I think quickest would be to do a partial revolve for like a mid-plane revolve with a total of 84 degrees. So we'll start off with that in line, or in mind rather, and start with this profile. So we'll start a sketch on our YZ plane, and I'm going to start with a reference rectangle, and this is going to be 40 millimeters by 16 millimeters, and then I'm going to put a midline constraint from the bottom line to the origin, and then go back in. We'll grab our 3-point arc and select from one side. Make sure you try not to trap onto the midpoint. Go to the other side and then just draw it down and apply a tangent constraint from the arc to the bottom line. And then finally a horizontal constraint between the two endpoints of the arc. And that's going to be dimensioned at 6 millimeters. And then finally go back in and grab our line tool, solid line, and just trace out around the rectangle to close that off and complete it. Okay, so now there's two ways to add the arc or the axis to revolve this. One is to draw a reference line and dimension this at 160, and then from your insert axis from sketch ribbon, or well, let's see, in your sketch tool, sketch ribbon, and it's not in the, okay, insert axis. Select your arc or the reference line, click apply and OK that, and then deactivate the sketch. So now we have our axis. Go back into revolve, select our sketch to revolve, select our axis, change this to mid-plane and change our distance to our angle to 84 degrees, and that completes that. Now to insert this axis, the other option would have been to select the YZ plane, go to Insert Axis, or from the Insert menu, go to Insert Axis, select the YZ plane, select the Z-axis, and key in your distance, and I'll just key in 175. And if you need to, you hit reverse, but that'll offset that on the plane, and click apply. So that would be your second option for inserting a plane. So let me just get rid of that one so we're not confused with it. Okay, now let's see, we need to apply some fillets on here. So we do a full round fillets here at 20 millimeters, and we'll just grab the verticals on each end. Okay, and close that. And then finally we do a shell of a thickness of 4 millimeters, and we'll remove the top face. Okay, and then we have basically our boat-shaped revolved part. Next, we're going to create the circles or arcs to complete or define our sleeve here. That's going to be 40 millimeters, and then it's an offset distance to give us a wall thickness of 6 millimeters for our steel pin. So we'll first start by inserting a plane, and we'll offset our ZX plane 40. And then on this offset plane, we're going to create our circles. First one will be 40, and then our second one, just select this origin and just drag it out, and we're dimension between the two arcs, 6 millimeters for the wall thickness, and then we'll extrude, change our depth type to next, and if you need to, hit your reverse button to make sure you're going in the right direction, and that'll go down to the boat shape part. And it completes our plastic part, except for material, which is ABS. Okay, now let's go ahead and save this. And we're just going to call this, what's it listed here? The ABS is part item number 1 on our parts list. So I'll change this as item 1. Okay. Now we're going to reuse some of the same geometry to create our steel pin. So let's go in here, we'll do a file, save as, and change this to item 2. And now, in order for us to reuse all this geometry, we're going to delete the extrusion, delete the sketch. We can leave the plane in here. We'll delete this shell, delete the fillets, and delete the revolution, but keep our sketch. So we're going to edit the sketch, and then in here I'm going to right click on the arc and select chain select, and then from the ribbon convert to reference figures. Next we're going to come up and hit our offset tool, and we're going to offset 4 millimeters and select our arc and flip the direction to make sure it's offset to the inside, and then just to keep from having to add some more dimensions, go to the constraints menu, select fixed constraint, and select the arc, and that locks that down. Now one more thing we're going to do is go back in and grab our 3-point arc, select the 2 endpoints of the offset that we just locked down, and just drag down so that you get kind of a looping teardrop shape here. And if you want, you can go ahead and select, you can lock this down too, so that that's fully constrained. So then we're done with that sketch. So now come down here and we're going to right click on our ZX plane, activate our sketch, and we're going to draw a circle for our pin. And this is going to be the same size as the wall thickness here, so we're going to dimension this at 40 minus 12, which is our wall thickness and all around. So 40 minus 12, and then we're going to extrude this for a distance. We're going to extrude that to a distance of 40. So key in 40, hit enter, and OK. You could have done that as up to geometry and selected this top plane too. It'd be the same thing. Okay, next is another arc. Activate our 2D sketch and draw a circle at 32. And this one we're going to extrude. We're going to extrude this one to a depth of 105 minus 40. So up here we're going to go 105 minus 40, and OK that. And if you want to double check that, we can just select the top face and the bottom face, and our readout here, distance in the bottom right corner, is 105. So finally we did add a chamfer on here of 8 millimeters and select the top face and apply that. So that's done. And finish this. As far as shaping it, we're going to do a revolve cut. Grab our modified sketch on the bottom, grab our axis, change our type to midplane. We're defaulting back to our 84 degrees from our original part. Accept that, and then we're done with that. And finally change our material to plain carbon steel, and finally save this, and we're done with our part. So now let me go ahead and close this, and we'll start a new assembly. Just grab all of our parts, and we'll just place them at the origin and finish, and get our windows squared away here. So now I just place them on the origin. Let me just do a right click. We'll insert a precise section view here, and we're going to section only the curved part. And you can see that everything looks to be fitting in there nicely. And as a final check, let's go in here, we'll get our physical properties, calculate that to one place, and we have 627.8 grams, which is what we required on our drawing. So there you go. That's how you can reuse the geometry of one part to create a second part for fit up without you could have probably done this in the context of an assembly, but in the context of assembly, I tried this before, you can't do you cannot extrude this to a surface and have it come out right. This is a nice clean method, so hopefully this helps anyone practicing on this drawing. So thanks for watching.